Today what we're going to be talking about is we're going to be talking about our fundamental theorem of calculus part 1. Now yesterday we did part 2, today we're doing part 1. I do them a little differently because I think explaining part 1 we need to know what part 2 is, in my personal opinion, but whatever. Okay, let's just worry about evaluating this integral and then eventually we're going to take the derivative of it. Okay, so we know what function's derivative is sine, that's the negative cosine of t, and we're going to evaluate that from x to pi. Meaning, and we're going to worry about taking the derivative here in a minute, we're going to have negative cosine of x minus a negative cosine of pi. Now, take the derivative of this function now. When I take the derivative of this function, let's notice what happens. Okay, what's the derivative of cosine? Derivative of negative cosine is the sine of x. Derivative of cosine of pi is 0. So what happens? Okay, because our integrals and derivatives are essentially inverses of each other, when you're taking the derivative with respect to x of this integral quantity, basically the x just comes in and becomes the new variable in your answer, because they kind of undo each other. So our fundamental theorem of calculus, okay, when I take the derivative of an integral, you just get your original function out. And every continuous function, f, is a derivative of some other function. That's an interesting thing to keep in mind. And every continuous function has an antiderivative. Okay? And I've been talking about this already, but integration and differentiation are inverses of one another. Okay. Now, think about this the short way. Don't try and take the integral of this quantity. I'm always going to give you some sort of dummy function in there that you can't take the integral of. Okay, but I know if I'm doing the derivative of an integral, they essentially just cancel each other out. So we get that function out. Same thing here. Okay, just remember we need to switch our signs because that's going to be the negative. The x needs to be on top, is to be the upper limit. So now when I take and I find this, this is just going to be negative sine of x. Okay. In this example, notice what we have there. We have a function as part of one of our integral limits. And I made it a function that we're taking the integral of to prove a point to you guys. So let's look at this. We have d dx. The integral of e to the t is e to the t, and I'm evaluating that from 1 to x to the 4th. Now, let's find the derivative of that. So we have e of x to the 4th minus e to the 1st. Now when I take my derivative of e to the x to the 4th, I have the derivative of the outside function, which is e x to the 4th, times by the derivative of the exponent, which is 4x to the 3rd. The derivative of e to the 1st is 0. So my final answer is 4x to the 3rd times by e to the x to the 4th. And I've done that in a different color for a specific reason for you guys. So when I'm taking the derivative now of an integral where I have some value, we have some function g of x, and then we have some function, I don't want to call it e, I want to call it f of t, or any dummy variable in there really, dt. So now what we have here is notice what we have. We have our function. We have our function, but what's our function is a composition of that function g of x. So f of g of x times by, so this is the f of g of x. What is that? That's the derivative of our g of x function. So what we have going on there is a chain rule. So we have so your final answer. So they're not always going to be functions that you're going to know how to evaluate. What your final answer is f evaluated at g of x times by the derivative of g of x. See, I told you it was going to happen. You don't know how to take the integral of that. Okay, this is that's f of t. This is some new function g of x. By that formula that I just gave us, we have to evaluate our function at our g of x and then multiply by the derivative of g of x. So we have the sine of the square root of 1 minus x squared times by our g of x function, but it's actually the derivative of that function. The derivative of that function is 2x. So our answer would be 2x times by the sine of the square root of 1 minus x squared. And that's all we can do. The next example, I have to find dy dx, but I have a number, I have functions in both pieces. So what I need to do is I need to separate this out. I need to set up basically a dummy variable or a dummy a. So I'm going to take the integral from 0 to 5x squared of the sine of t dt plus the integral from 3x to 0. Because remember, I can separate that out, and I just came up with some number. It can be really any number you want. So now, what you also need to keep in mind, remember that the function for our formula that I gave you guys to work, the function needs to be on top. So it needs to be our upper limit. So how do I change those? I change it to a negative, the sign to a negative, and we go from 0 to 3x, the sine of t dt. Now when I find d dx of both sides, I find d dx of both sides. I have dy dx on the left, and now on the right. Okay, that's the formula we just did. The sine evaluated at our g of x function times by the derivative 10x. Now subtract, and we have the sine of our 3 of x function evaluated times the derivative of that, which is 3. So that is our derivative of our y function. Okay, that's it for our fundamental theorem of calculus. Please make sure your lesson summary is submitted on time.